Running Windows with defective RAM. Is it possible to run Windows 7 x64 with a defective RAM module? More precisely, is there some way to tell Windows not to allocate a known bad address or block of addresses? For Linux, there is bad RAM. Is there an existing implementation for Windows? Is that even possible with Windows kernel, NT 6.1? Maybe a kernel mode driver.
Bob, there's 3 parts to your question. I'll address one at a time. Running Windows with bad memory. It is indeed possible to run Windows 7 with a defective module. Depending on the location of the bad sectors and where the module sits in your DIMM banks, Windows 7 will run like there's nothing as long as it doesn't try to touch the bad portions of the memory. So, ideally you'd move the defective module as far away as possible from bank 0. Naturally, if this is your only module, you are out of luck. Blocking bad memory sectors in Windows. On x86, 32 and 64 bits, operating systems, memory is managed by the kernel. As you mentioned, badmem is able to block bad memory sectors in Linux. It works by instructing the kernel to lock those memory addresses you specified. This effectively stops Linux from ever addressing those addresses when allocating and deallocating memory. But in order to do this, badmem needs to patch the kernel. Badmem is nothing more than a kernel patch that you configure before applying. Now, you don't have that ability on Windows. You cannot patch the kernel. Developing a kernel mode driver won't do you any good either, since the Windows kernel will never let your driver take precedence over its memory management architecture, understandably so. For this reason, you cannot instruct Windows in any way to not use certain memory addresses. The only way would be for Microsoft to patch the kernel for your case specifically. Unlikely. The spreading of bad memory addresses. There are not many reasons why a memory module may contain bad addresses. Ultimately, it all boils down to an error in the production line, assuming it didn't sustain damage before getting into your computer. Contrary to hard drives, there's no movable parts in memory modules, as you well know. So, bad sectors don't tend to spread, as is the case with hard drive sectors. However, memory test software isn't foolproof. It's possible, and common, for it to pass certain addresses that are in fact bad. So bad memory may give the impression of spreading as more and more addresses are revealed to be bad. For this reason, tools like badmem reveal their weakness, because naturally they can only handle those addresses you instruct them to. It's unlikely that anyone can conduct a thorough test of a memory module and identify all bad memory addresses, then lock them and end up with a good memory module. The easiest thing to do is to consider a module with bad addresses as a defective module throughout and consequently not to be trusted. What this means is that, as much as badmem is an attractive proposition, it in fact isn't a solution to the problem of bad memory. More likely than not, you'll still end up with an operating system that tries to read a bad sector and crashes with a stop error. A bad module is a bad module is a bad module. The Windows BCD, boot configuration data, actually has a bad memory object. It seems memory addresses that are predicted to fail by ECC memory will be listed here, and not used by the operating system. The bad memory object accepts a bad memory list, BCD type 0 by 1700000A element, which is a list of integers that can be entered as hex, separated by spaces. I guess it would be possible to manually insert bad memory addresses as found by mumtist86 to this element, but I have not tested this. Apparently, it accepts page frame numbers, which is the actual address divided by 4096. Unfortunately, these addresses /pfns may not match those reported by memory diagnostics. Manual editing can be done with Visual BCD Editor. In any case, faulty memory sticks should be replaced as indicated by the other answers. This is merely a note on a possible way to work around the issue, temporarily. Mumtist 86 Pro, not free, can produce the correct blacklist commands for you in its report. Other answers describe the process for doing so manually.
I had trouble RAM in a tablet with SOAK. Memory is welded or integrated into the SOAK and cannot be replaced. I am in Argentina and the seller is in China, and the shipping costs and time, it makes no sense to send in warranty. I managed a few hits. The key to passing the damaged memory parameters are: addresses in Mentis 86 match addresses used in Windows. Must mark full pages of 4 kilobytes. In Mentis 0 by 10 million corresponds to 0 by 10,000 in Windows. In Mentis 0 by 0.0001000 corresponds to 0 by 1 in Windows. Means, the page number in Windows removes the last 3 Mentis hexadecimal numbers. Means that, Windows eliminates zeros in the left. Consider 5 and 6, to avoid errors in the page numbers. The correct statement is, /set, bad memory list 0xb70xb80xb90xb, to errors in Mentis from 0 by 000b7000 to 0 by 000baf. Note that you cannot put a range of memories, but all pages one by one. Cannot add pages. All pages should be marked in the same command. If a new page, adds overwrites older. I managed to add 4096 pages in only command. I haven't tried it more. /nu, bad memory, shows the list of marked pages. /set bad memory access now, prevent the marked pages are used. It is necessary to reboot after marking pages and remove access.
Windows BCD has bad memory list and bad memory access objects. You should set the first bad memory list to bad memory pages separated by spaces, e.g., pictedit/set bad memory list 149.95431434007, and the second bad memory access to no pictedit/set bad memory access no. Bear in mind that memory page size in Windows is usually 4 kilobits. Test it in Windows 7 and it works well. You can test your settings with RAM app util by sysinternals. P.S. I've got that info from Windows Internals Book Chapter 10.
If you want to support the channel, please consider subscribing.